Hello everyone. Good morning. Are you able to hear me?
Yes, Venkat.
Yeah, Venkat.
Yeah. So let me share my screen quickly. So today we'll try to discuss few things related to BigQuery. So hope you're able to see my screen.
Yes, Venkat.
Okay. So today we will try to discuss few important things in BigQuery. Okay. So I thought of discussing incremental load today, but it's not the right time because when we were discussing about the project use case, that time we will try to discuss about the implementation of incremental load and then processing and then orchestration. We'll see all together in the project use case discussion. Okay. So but now let us understand about BigQuery, and then we will try to uh, complete the core BigQuery concepts. Then we will see about these load patterns implementation in the end, at the end. Okay, so that is what the idea. So for today, let us focus on few things. So I just want to explain you what we are going to discuss today. So today we will try to discuss a few core BigQuery concepts. So the first thing is tables in BigQuery. Okay, tables in BigQuery. So we have two different types of tables. One is external table, another one is native or managed table. Okay, so we'll see the difference and we will try to uh, create few tables. Okay, so and then after discussing these about tables, we will jump into the partitioning in BigQuery. Partitioning in BigQuery. Okay, and then we will also see the clustering in BigQuery. Okay, so these are the concepts that we're going to discuss today, and while discussing these concepts, I'll also explain the stored procedures in BigQuery. Okay, so quickly, let's start with tables in BigQuery. So we have two major types of tables in BigQuery. Okay, one is the external table, another one is internal or native or managed table. Okay, so external table, internal or managed or native BigQuery table. Okay, so these are the two types of tables that we have. Okay, so what are these two types of tables? So let us understand. So when we create an external table, right, so you can actually store data in GCS. Be very very clear. So what do I mean by external table? The external table data store. Okay, and here the data will be stored in a Colossus, right? So you need to understand this difference. This is the simple difference. So external table, the data will be the data files will be stored in the GCS, and what we do, we create a BigQuery table and we'll point the table to the GCS locations. Okay, that is the external table. But when we say internal table, we create the table and we load the data, and that data will be stored in the coalesces storage layer, which is internal to the BigQuery. Be very, very clear. This is the major difference between these two table types. Okay. So, if you, some in your project, sometimes you will create external tables as a stage layer, and then majority of the times in our projects we create native BigQuery tables. The reason being, native BigQuery tables allows you very huge performance compared to the external tables. Okay, so that is the only reason you can create external tables. You can create external tables in the form of stage zone or something, but the target tables most of the times we create with native BigQuery tables. Okay, so this is the difference, and let us quickly understand how actually we can create an external table, right? So here, if you see, okay, so here, if you see, I'm creating a table, right? So here, this is my notebook. Okay, so let me try to reopen it. Just give me a minute, guys. So, okay, just 1 minute, guys. I'm coming back. Okay, are you able to see my screen?
Yes,
Yes,
Venkat.
okay.
Yeah, Venkat.
Okay, fine. So I've started my notebook here. If you see the Vertex AI notebook, then I'm just opening it, the Jupyter Lab. Okay. So the first and foremost thing is, let us try to understand how we can create an external table. Okay, how we can create an external table. So here, if you see, I'm creating an external table using a BigQuery command. Okay, so I'm creating an external table using BigQuery command. Here, if you see, BQMK means make, and here what I'm doing, external table definition equals to Parquet, and I'm pointing this to my GCS path, and I'm maintaining this or appointing this to a table called, let us say, test underscore data. Okay, so if we execute this particular BigQuery command, BigQ make external table definition equals to Parquet, and then equals to passing the Parquet file. Okay, passing the Parquet file paths, right? So star.parquet I have given here, if you see the regex. So in this particular path, if I place whatever the Parquet files, then obviously your table will be picked up those Parquet files. So and then I'm pointing this to a table. So I'm making a BigQuery external table pointing to the GCS location. Okay, this is what the external table meaning. So now here, if you see test data external. So when you do this, what will happen? So it will create a table. Okay, and this table you can actually go and check here. So you just created it in the default dataset, right? So you need to go to default dataset and then refresh. Yeah. So here, if you see, you just created the external table, right? So whatever the Parquet file that you loaded, so it will be loaded into this table. Okay, so if you see here, this is the external data configuration. So your data is outside your coalesces. Okay, but if you take any managed or native table, so usually we used create table statement and we loaded the data, right? So if you see any of the managed table or a native table configuration, so you will get a preview option because the data is available to its storage, right? So your coalesces storage being used for storing the native tables data, but for your external table you don't see that option called preview, right? And when you go to details, you will see the storage information as this, right? So this is how you can actually identify the difference between the native table and external table. Okay, so can we query these tables? So, okay, we created an external table, so can we actually query these tables? Let us quickly understand how actually we can query these tables, right? So here, if you see, as like you are querying, you can actually querying native tables, you can query all the select statements, everything you can query. Okay, on top of the external tables. So this is something that you need to understand. So we can use all our queries on the external tables as well, but the query performance will be little less compared to your native tables. Okay, and native tables have few other features also, like querying with wildcard. Okay, so meaning, for example, you have 10 different native tables following a naming convention like this. Okay, like this. So following a naming convention like this. Okay, so like this, they are following a naming convention, native tables, right? So you can query all these tables at once by using the wildcard based notation. So you just pass the star here, so you can query all the tables that are there with that naming convention. Okay, that is the biggest advantage with native tables, but in external tables, so you cannot do that. Okay, so that is one thing. Okay, so I think we are good with external tables and internal tables. So external tables will be created outside the BigQuery storage by using a GCS location, but native tables will be created internal to the internal to the BigQuery, and the data will be stored in the coalesces. Okay, so that is the major difference. If you use normal create table statement, if you use normal create table statement, so this create table statement will be creating a table in the native coalesces storage. Okay, but if you want to create an external table using the create table statement, so you need to use the external keyword. Okay, you need to use the external keyword. So here this is the external table creation statement. Okay, so you can create using BigQuery command, and you can also create using uh, create table statement. Okay, so this is create external table and the data set and the table name and options. So let's try to create this and see whether it will. Okay, so my data set is test underscore data, and then I'm just creating a table called dummy, and I will use this path. So in my URIs, I need to pass this path. Okay, I just need to specify the parquet. Okay, so when I do this, let's see whether it will create. Yeah, so your table got created. Okay, so now let us try to quickly go ahead and check fresh contents. Yeah, see here. You created an external table using the create table statement also. Okay, so this is how you can create the external tables and the internal tables. So normal create table statement, right? So if you do that, then it will create the native table. Okay, but if you specify the external table external key with the external keyword, then it will create the external table. Okay, so that is the major difference. Fine. Any questions or queries in external tables and the native tables, guys? Any questions?
Clear.
Okay.
Venki, one
Yeah.
doubt.
Yeah.
Does it make any difference in performance wise?
Yes, yes, it will make difference. It will make difference. So your BigQuery native tables, as I was mentioning, your BigQuery native tables are very performant because the data is native, or the data is stored
Okay.
in its own place called coalesces, right? So your queries on top of the native tables will be more performant compared to your external table query.
Okay.
Yeah, because the external table will go and scan all the GCS locations, and then in real time, here it is a single file. You don't see the difference, but in real time projects, you will see terabytes of data.
Mhm.
So that data, if you want to hit and apply a filter on top of it, and then if you try to query it, then it will take a lot of time if it is an external table case. Okay, but if it is a native table, you have a lot of performance optimization scopes wherein you can apply partitioning, you can apply clustering, and then you can query based on that. So your BigQuery will give you more faster results if it is a native table and with a lot of optimization scope that we have. So we can optimize native tables more compared to external tables.
Okay.
So yeah,
And one more doubt.
yeah.
Once we created the table, how we can find it's created by native or it's created as external table in BigQuery?
Uh, that's what I was showing you, right? So the external table configuration, right? So here, if you see, if you go to the table details,
Okay.
right? Here you see external data configuration,
Okay.
right? But if it
Okay.
is a native table, you will see the storage info. If you go to details, you will see the storage info. This storage
Okay.
info won't be available for the external tables. So external tables storage info will be external data config. That is what it will just show. If you just go to details, you'll simply find it out. See here.
Yeah, got it.
Yeah. Okay.
Thank you.
Fine. So this is about external tables. Okay. Sorry, external tables and native tables. Fine. So now let us quickly see. Can we create some partition based paths for external table, right? So you can always do that because BigQuery will support some Hive related partitioning techniques. Okay, so that also you can do with external tables, but which is very limited, and you need to create your paths with this fashion. So before going to that, first let us understand what is partitioning. Okay, what is partitioning and what is clustering, right? So we'll try to understand that concept first, and then we will jump into how to create a partitioned external table, how to create a partitioned native table, right? So all these things we will see. So now, anybody have any idea on what is partitioning in data warehousing, or any uh, any database management systems? So anybody have any idea on what is partitioning? No.
So, partitioning is all about splitting out the data and processing in parallel.
Okay, okay. Any other answers?
Dividing database for better performance.
Okay, okay. Fine. So let's understand what is partitioning first, guys. Okay. So partitioning means partitioning your data that is stored in the table based on a column. Okay, based on a column, so that you can increase your query performance we'll see. But remember, partitioning and clustering, these two are the optimization techniques in BigQuery. Okay, they can reduce the cost for you. If you implement partitioning and clustering on a table, you can save some cost for query execution. Meaning, when you are executing queries on a very huge tables, the table scans are very costly in BigQuery. The table reads, for example, you are querying a 1 terabyte table and applying a where filter on top of that 1 terabyte table, and that query costs you a lot. Okay, but if you partitioned the table, if you applied a proper clustering keys, and then you are querying the table with the partition keys and then cluster keys, then in that case the query performance will be very much optimized, and the cost also will be reduced because the table scans will be less. Okay, so the major intention behind this partitioning and clustering is to reduce the table scan, to reduce the table scan. Okay, so let us go a little bit deeper into partitioning first, and then we will see clustering later. But let us go a little bit deeper. Okay, so now partitioning, we know. So partitioning means splitting or partitioning or dividing the table data into multiple chunks or multiple partitions based on a column value. So how we will do that? So let us quickly understand. Here if you see I have a data called release date, movie name, and then genre, right? So here if you see the data, this is my data set. Okay, and if I apply a where clause on this data set, Okay, if I apply a where clause on this data set, which is not partitioned, okay, and I'm applying where release date equals to 7th April 2022. So now what my query engine will do, my query engine will go and scan my entire table. Be very, very clear, because it has to match all the records to which are satisfying your where clause, correct? It has to go to each and every record and apply your condition and check. If it passes, then it has to return the output, correct? So that's how your where clause will work. Now what will happen when you apply a where clause on a non-partitioned table? It will go and scan your entire data. Be very, very clear. It will go and scan your entire data, whether it may be 1 terabyte or 10 terabyte, it doesn't matter. So to scan, what will happen from the Dremel, the leaf nodes will launch slots. Okay, if your scanning is very huge, the leaf nodes will launch more slots. So when these leaf nodes launches more slots, what will happen? The cost will be very high. So your BigQuery will be charged based on your slots and slots time. Be very, very clear. Your BigQuery will be charged based on your slot consumption. Okay, so each slot is a complete service for you. Be very, very clear. Okay, now what will happen when you apply a where clause or a select star from this table or select a particular columns from this table, and then when we try to query using the where clause for a non-partitioned table, so it will go and scan all the records. Be very, very clear. It will go and scan all the records. And remember, BigQuery is a columnar data store. Be very, very clear. Meaning, like our Parquet files, and then like ORC, it's a columnar data warehouse system. So you should not apply select star on top of the BigQuery tables. Be very, very clear. Keep this in mind. You should not apply select star on top of the BigQuery table. You have to select the column names. Okay. Select employee name, comma, employee ID, comma, employee salary. That's how you need to write your queries. You should not apply a star. Okay. So because it's a columnar store. Now coming back to the partitioning, so if you apply a where clause filter on top of a non-partitioned table, it will give you more table scans. More table scans will charge you more cost. Okay, that is the purpose here. So now how to avoid this, how to actually save our budget, right? So in that scenario, we will partition the table. Okay, we will partition the table based on a column. Okay, so what do I mean by that? So here I have a release date column. So based on that, I will partition my table. So internally, the BigQuery organizes the data into multiple partitions, okay, based on this column. So now how you will select the partition column? So your partition column selection is very, very important. So it should be one to many relation to your table object. Okay, so what do I mean by that? So for one release date, you can have multiple movies, is it? It's one to many or not? So that is how you need to select your partition column. So the relationship always should be, the cardinality always should be one to many. Okay, so then only you need, that column will be identified as a partitioned column. Okay, if the column is unique, it is strictly not recommended for the partitioning. Be very, very clear. If the column is unique, it is strictly not recommended for the partitioning. Now what is the advantage of partitioning? Now let us assume you partitioned your table based on the release date. Okay, BigQuery, when you say hey, partition this table, then BigQuery, what it will do, it will take that column reference and it will partition your data, and it will organize this in policies in such a way that, okay, this is partition 1, this is partition 2, this is partition 3, this is partition 4. Okay, and it also stores the value. Okay, this is partition 1, having the value of 17 April 2022. Okay, and then what it will do, it will make note of all the partitions that are linked to the table. Okay, so then what will happen when we apply a where clause on the partition table? Now let us assume I'm querying select movie name from partitioned table where partition equals to where release date equals to 17th April 2022. Okay, so when I do that, what will happen? BigQuery internally go and search the metadata of the table. Okay, and from the metadata, it will pick that partition, and it will go and scan only that partition. It won't go to other partitions. Okay, so in this case, it will scan only this partition. It will leave all these partitions because the data is already partitioned, right? So this is one of the biggest optimization technique that we need to recommend with respect to BigQuery, right? So this is the difference between a partitioned table and a non-partitioned table and a non-partitioned table. So when you do a query or apply a where clause on the non-partitioned table, it will trigger the full table scan, which will add more cost to your project. Okay, but when you partition the table, internally BigQuery organizes your data in a partitions. Okay, for partitioning you need a column. Okay, and that column selection will be based on the cardinality. Okay, and it should be always one to many. The data elements in that column should be duplicated, be very very clear. Okay, then only it can be suitable for a partitioning column. Okay, otherwise we cannot create partitioning on unique columns. Be very very clear. Okay, I have a primary key column and I want to create partitioning on the primary column, which is not possible or which is not recommended to do, because it will create too many small partitions, and too many small partitions, the metadata will be increased, and again it will be very burden for BigQuery to identify the partitions. Okay, so that is the reason we always recommend to create a partition on the right column, right? How this column along with the cardinality, there is one more thing that you need to consider. So from the user interface, from the downstream, so if the downstream is querying on a regular fashion on these date columns, then also you can actually partition on that column. So if downstream is not querying, then we will recommend them, hey, query on this column so that you will get better performance. Okay, so what do I actually mean by that? Let us quickly understand. Okay, here I have a table, emp table, and this emp table will be I have employee id, employee name, salary, and then department number. Okay, now in this table, so I my data science team, right? My data science team is querying like this: select star from emp where employee id in, okay, and department number in. Okay, so they are querying this, right? And when this query is happening, this table is not partitioned. Okay, this table is not partitioned. So if this table is not partitioned, right, so what will happen? Your data science team will be reading this table, and then they are executing this particular query, and what will happen? It will go and trigger the entire table and assume our table size is 5 terabyte. Okay. Now, so your table, your query will be auto scaled, and it will launch as many slots you need, and then it will try to complete it, and then it will cost you a lot. Okay. So now, okay, so every time you're getting this kind of a query from your API. Okay, every time you're getting this kind of queries from the API. So in that case, what you do, you apply the partition, right? You apply the partition. So here, if you see partition by department number, okay, partition by department number, and if they need further optimized, then you can simply say cluster by employee ID. Okay. So we'll see cluster by later, but for now, understand partition by. When you do partition by, so they are using your partition filter in the where clause. So assume the downstream queries should use your partition filter, should use your partition column filter in the where clause. Otherwise, they won't get the advantage of partitioning. Be very very clear. This is one of the limitation that you need to understand. Okay. So if okay, we partition the data on a specific column, and we are not using that column in the where clause, then how BigQuery will understand, right? So you need to have that understanding on how to utilize your partition tables, right? So this is very important, guys. Okay. So you created a partition table and you loaded the data into partition table, and then you're querying the partition table, right? So your partitioning happened on a specific column for a reason, correct? So, and if you're not using that column in the where clause, then your BigQuery doesn't know, okay, so he is not utilizing the partitioning. Okay. And few examples are there. You can actually enable the mandatory partition filter. Okay. That is also possible in BigQuery, meaning if the downstream query, if I'm writing a downstream query from the data science team, assume I'm querying my partition table. Okay. If I'm not giving any partition column based filter in the where clause, then my query won't run. It will trigger an error. Hey, you need to provide partition filter in the where clause. Okay. That is that kind of intelligence it is there. You can enable to BigQuery tables. That is possible. Okay. So that end users can provide filters, appropriate filters, so that they'll see the optimized query performance. Okay. So this is about partitioning, guys. So any questions or queries in the partitioning? Any questions or queries in the partitioning?
uh, Venkat, you just
Yeah.
told me told us based on uh, release date you have partition, right? So why can't we go with genre? So it's also like one to many, right? Action we are having, and then based on the action genre, in the action genre we are having multiple movies, right? So uh, that's
Yeah,
also
that
kind
is
of
what
one to many.
yeah, here there is one limitation in BigQuery. You cannot create partitionings on the string type columns.
Okay.
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 You cannot create partitioning on the string type column. That is the limitation in BigQuery. You can create a partitioning on the integer column, and you can create a partitioning on the date column and timestamp column. So these are the three options that we have in BigQuery. So majority of the times in real-time projects, we prefer on date column. We prefer on date column.
Okay.
Okay.
And
Yeah.
one more thing
So
is
yeah.
suppose, yeah, as you told, based on the slots created, they'll charge the amount,
Yes.
right? So
Yes.
can we know, for example, I have written a query, and then
Mhm.
the same query can be written by others in some other way. So can
Yes.
we know that how many slots created for this particular query, or for other query how many slots created? So can we know the slots
Yeah, yeah,
created?
we can. You can actually see the slot consumption in the query execution plan. So let me. You can see that. I'll show you. So in the execution details here, if you see, you won't be able to see how many slots got assigned or something like that. But you can see the slot time consumed, and it will give you the number of slots calculation also. I'll explain that when we were at execution stage. Okay, so here if you see your query execution graph also you can see, and then execution details. So in the execution details you can found what is the slot consumption and how much time it took to allocate the slots, right? So all these things you can see, what is the physical execution plan for your query, all these things you can see. I'll explain that
Can
part in
can
the
we
coming
see
session.
that in detail, or like how it will be? Like for example, I'm having a query with multiple multiple subqueries. So will it
Mhm.
show like for this particular subquery it is taking time? Is that like that?
Yeah, it is like that only. You can see the
Okay.
graph. Okay,
Okay.
execution graph. That means filter, join, and then you will see. I don't have very big data set at this moment. Otherwise, I would have shown you. Let me try to query one. Okay, I have something in my MPDB. So let me query this table. So this is how you will actually see the graph. Okay, so if you can see the number of slots also consumed here. If you see S00 is the slot ID. Okay, and if you apply all the joins, right, your graph will be splitted into multiple boxes. Okay, so I'll get a very complex query and then execute and show it to you. So it is like a graph. Okay, tree kind of a stuff. So when from the data store, how the data is flowing and how many records each step is getting, and then after execution of each step how many records it is outputting, all these things you can see in the execution graph. And you will see
Okay.
the duration also for each. So one thing is we need to apply that kind of a complex query, and we need to discuss. So we'll discuss it because we need to apply these unnest queries and then left join, inner join, all these queries on these tables, right? So definitely when we were at that stage, I'll explain you. But yes, so to answer your question on a straightforward, it is possible in BigQuery, and it is in a more matured fashion, unlike other database systems. It is not like execution. What we can say, it is not that much complex to understand the execution graph of a BigQuery. It is very simple and straightforward. Okay, so here in the execution details you can see the slot wait time, how much time it has waited for slot, and then read time, and then compute, and then write time, records. So everything you can see. So if you see the slot details, so here if you see the stages, so every information related to the execution you will be able to get it.
Okay, and one more question about this. Like, is there anything like this is under below only the wait time should be like, for example, it should be if we take some APIs, if it is a get API, then it should be like 150 milliseconds. It should give the results. So in such a way, do we have anything like this in this? In
Yeah, so it depends on the slot selection, right? So organizations, how they are planning to utilize the BigQuery. Let us take an example. My organization is planning to utilize it for a batch analytics. Okay, so now in that case, what I will do, I will go for a fixed slots. Okay, I'll go for the 10,000 slots per month. Then I'll pay for the 10,000 slots, and I'll share the 10,000 slots across all projects. That is one way of utilizing the slots. Other way is I'm having all the APIs enabled on the BigQuery, and I need a high demand or on demand slots. So in that case, there you don't see any kind of a waiting as such. Okay, you see a waiting on fixed slots usage. You see waiting on the fixed slots usage. If you select on demand slots, meaning as and when the request comes in, immediately the slot should be assigned. So if you are going that slot consumption approach, then definitely yes, you will get that, and it will be more costly.
Okay.
Okay, so that's the reason. Majority of the times, if the APIs are hitting and then continuous reads are happening from the APIs, then it's good to store the data in the NoSQL database. So BigQuery is for the data warehousing, analytics, and reporting purpose, and for the batch periodical ML models to run. It's not for the live streaming, right? So that is something that we need to understand, the difference, a small difference between the data warehousing and the NoSQL database. So if your API is continuously reading the data, and if your API needs fast fast read performance, then we need to store the data in the NoSQL data store. Okay, and if your API is okay with the read performance, but it needs to load the report, then we'll go for the uh, BigQuery. That's the minute difference that we need to think of here. And it's not like BigQuery doesn't support API reads. It will support, but the data, because of the data volume that it holds, the time that is going to return the output will be little bit high compared to NoSQL databases. The NoSQL databases, because of the row key filter, you can read the data very much fast. So it's the decision, architect's decision. If your project have a lot of APIs and they are continuously doing the reads based on particular columns, then the data will be stored in the NoSQL database. If your data is serving a batch-based machine learning models or a batch-based reporting, then you can go for the BigQuery. So that's the option or the decision taken by the architect. Clear?
Yeah.
Okay. So yeah, so this is something that you need to remember is on-demand slot consumption, fixed slot consumption. Okay, fixed slot consumption means they will assign, Google assigns 1,000 or 10,000 slots to you per month, and you will pay for that 10,000 slots only. Now internally, what Google will do, they will try to make the 10,000 slots available, and all the projects they will connect to this 10,000 slots only. Now what will happen? The 10,000 slots will be shared between all the projects, and that that will actually create a shared space. Because of this shared space, what will happen? You will see the waiting time, but there will be few critical projects. Okay, there will be few critical projects, and where they don't want this waiting time. So in that case, they will go for the on-demand slot consumption. So when they select on-demand slot consumption, when they enable this on-demand slot consumption for a specific, so it will try to pick the slots from a dedicated pool. So that dedicated pool slots are very costly. Okay, so in my org, we typically use the fixed slot consumption, but there are projects which are using on-demand slot consumption also. So that is actually the project specific. Okay, so that is about the thing. So any other questions related to partitioning, guys? Any other questions related to partitioning? We will see how to create partition table. Okay, don't worry, we'll see how to create partition table, how to load the data into a partition table. We'll see that. But try to understand what is partitioning, okay, and what is the importance of partitioning, right? So why we use partitioning, okay? These are the three things I just want to be very clear, okay? So partitioning is the organizing of your internal BigQuery data into multiple partitions, okay, or dividing your table data into multiple partitions. Why we need partitions? To avoid full table scans, okay? What we'll get if we avoid full table scans, we'll get two things. One is query performance, another one is cost saving, okay? So these are the things that you need to understand, okay? Any questions on this theoretical thing? And I think hope we are good with the external tables and native tables also, right? So today what we have discussed about external tables, we have discussed about native tables, what is the difference, okay? And we have discussed about what is partitioning, why we need partitioning, and what are the advantages of partitioning, okay? So these are the things that we discussed. So any questions on these concepts? Come on, guys. Any questions? Okay, so yeah, everybody solved yesterday's tasks that I have given.
Yeah.
Yes, Venky.
Okay, great. So let me spend some time and see how actually you have done. Hmm. Yeah, okay, Bablu, could you please explain what you have done? Yes. Hmm. Okay. 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 Yeah. Great. 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 Hmm. Okay. So you used fetch GCS object and then you are loading it into BigQuery table. Great. Great. Good exploration, Bablu, and it will really help others. Guys, anybody did this fetch GCS object processor? Anybody? Anusha,
Yeah.
Prakati, Sai, anybody?
Yeah.
No, Venki. I did in
Okay.
Python.
Yeah, so try to explore this fetch GCS object processor. Looks it is interesting because like we have get file, we have fetch GCS object here. So we have get file, we have fetch file process in NiFi. So fetch GCS object is another processor to fetch the GCS files. That's good. Yeah, even I was not aware that it was there. Thank you, Bablu. Yeah. Okay. Yeah. Yeah. Okay. 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 Fine. Okay. Thank you. Thank you so much, Bob. So you tested this pipeline, right? It is working. Yeah. Okay. Okay. Great. Great. Fine.